Good evening to everyone present here. It gives me immense pleasure to welcome you all to the fifth day of Faculty Development Program on Innovative Healthcare, leveraging AI and ML for advanced biomedical signal analysis. On behalf of Department of Electronics and Communication Engineering and Biomedical Engineering AVIT, now I welcome our beloved HOD ma'am, Dr. Elka Hema, to give the welcome address.
Thank you, Ms. Ramya. So, on behalf of our management, Arbadividi Institute of Technology, Vinayaka Missions Research Foundation, Department of Electronics and Communication Engineering, and the Department of Biomedical Engineering, I extend a warm welcome to all the participants during the fourth day of this 5 days faculty development program. I extend my hearty welcome to our beloved Professor Dr. D. Vijendra Babu sir, who is going to share today's session with us in the title Digital Twin Technology and its application to healthcare, which are going to benefit the societal needs. So next I welcome all the faculty members, the learned professors, and the research scholars from various institutions who have joined here to learn the recent happenings, the advanced technological interventions that are taking place in the healthcare domain, which are facilitated by the various experts from industry as well as academia. So today we are going to have one such wonderful session, which is going to be presented by our professor. And Vijendra Babu sir was a colleague, and I worked along with him since 2009. He was my HOD as well as the professor in the Department of ECE at AVIT. And he has shown very professional development in the department in the form of academics, in conducting various conferences and symposiums. And he holds the position of vice principal in our institution. And due to his career prospects, he moved to now VIT Vellore. And even though he has shifted to another institution, whenever we need some help or whenever we need some expertise in the respective domains, he is always available, and he is always wholeheartedly helping us in all perspectives. Thank you, sir, for your kind support and the knowledge sharing with us. And today, it is our privilege. Once we invited him, he immediately accepted our invitation, and he is going to deliver technological development using digital twin. So it is technology which is used, which is very much needed in the healthcare domain to simulate the various sensory parameters received from the human body. So before analyzing the signals, we are going to have the simulation, so the decision making as well as the better diagnosis can be achieved through this digital twin technology. And sir is going to have the real-time implications of digital twin. And I once again welcome you all to our 5 days faculty development program. And we need your cooperation by way of sharing the constructive feedbacks as well as the questions. You can interact with the resource persons through your knowledgeable queries. Okay. With this, I conclude my welcome address. Thank you all.
Request Ms. Ramya to read out the SAR profile.
Yes, ma'am. Dr. D. Vijendra Babu sir is an associate professor in the Department of Embedded Technology, School of Electronics Engineering, Vellore Institute of Technology, Vellore. He earned his PhD from Jawaharlal Nehru Technological University, Hyderabad, and holds over 25 years of experience in education, research, and administration. He has published 95 research papers in reputed SCIE, Scopus, WS journals, authored 8 books and 3 book chapters, and holds 3 Australian patents, 1 Indian copyright, and 5 Indian patents. His areas of interest include IoT, wireless sensor networks, wearable computing, and machine vision. Dr. Vijendra Babu sir has chaired numerous national and international conferences, delivered over 70 invited lectures, and organized AICTE adult FTDs. He is an active member of several professional bodies, senior member IEEE, fellow IETE, and life member ISP and BES. He currently serves as Vice Chair, IEEE Robotics and Automation Society, Secretary of IEEE Vehicular Technology Society Madras Section, and Executive Committee member, IET Chennai Center. A recipient of multiple awards from various organizations, he continues to contribute actively to the academic and professional community. With a great respect, I now invite Dr. Vijendra Babu sir to begin today's session. Sir, the session is over to you. Thank you, sir.
Thank you, madam. Thanks for the warm introduction. I'm happy to come back to the place where I had been working for the past 23 years, from 1999 to 2022, if I'm right. And happy to see Dr. P.C. Kavita, madam. She was also a former colleague when you were working during 2000, and she was back. And happy to see many faculty members are working there. And thanks to the management, principal, and Dr. Hema, HOD professor, for inviting me for this FTP. So let me get on to this topic. Shall I share my screen, madam?
Yes, please, sir. Please, sir.
Yes,
Yes,
sir.
madam. Is it visible, madam?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay, madam.
Yeah.
Yeah, 1 second. Good evening to all present here. This is a wonderful topic which has been selected by the authorities, which talks about 5 days online FDP on next generation healthcare, leveraging AI and ML for advanced biomaterials and signal analysis. And out of this, I think it is the day 4 which I am going to addressing today on digital twin enabled intelligent healthcare services for future societal needs. It was being introduced by members of AV, ITV, MRFU. So I get on to this topic, and prior to get on to this topic, I need to explore about my institution where I belong to. As we all know, about Vellore is famous for many scenarios, and one is about the fort, which is the start point of our Independence Day. Then the famous CMC Vellore, CMC. Then about the Golden Fort, the Golden Temple. Then about our institution, which is more recognized for our world. And these are all a few credentials about our university, which I want to share with you. These are all different campuses, accreditation and rankings of our. These are academic blocks, and these are the hostel blocks. And I wish to share a few thoughts about those who are introducing faculty members who wish to go for a PhD full time. There is a good scholarship available. The exams to be on January 26. In terms of direct PhD, so BTech student can get on to MTech directly, or PG students can get on to Vitri. Scholarships are given. You can check the website. 1 more month is there. I think you very shortly the application is closing. These are the stipends. So now I get on to this topic. I hope the screen is moving. Is it visible, madam?
Yes, sir. Yes, sir.
Yes, fine, fine, fine. Now I get on to this FTP overview, uh, which talks about overall it's about integration of AI, ML, and in terms of medical signal parameters, where we talk in terms of more in terms of the leveraging the technology. As we know that healthcare is evolving, is an evolved sector. Out of it, we can proudly say that India, especially South India, we could have more amount of patients visiting us for better treatment and analysis and comparing across globe for better treatment on cost effectiveness. And in also scenarios and more industries and after COVID, we could see that more focus is on about healthcare sector. The evaluation of the disruptive technologies, we are getting on into more technologies involved into analysis of our human anatomy and these signals, what are extracted from our body, and the impact of AI and ML. This we can see here. So day to day, we could see here the impact of this, which we are getting benefited across it. Out of it, we could see this FTP opens an eye across what are these options to get onto this. And very specifically, it talks mostly about the biomedical signal analysis, which we talk more in terms of electrocardiogram, which talks about this activity of heart on EEG, EMG, and PPG. So, which are all different types of signals we need to analyze in terms of how complex in terms of nonlinear signals. As we know that when you're discussing in terms of linear and nonlinear, the complexity in analyzing and evaluation and testing, validation, and predominantly acquire about these signals and to analyze about is a very challenging process where AI and ML provides helps in all those things where we are getting into more into automation. And this, in terms of it, we will be getting much more. Even if we get on into few research articles which are published, we will be more seeing in terms of different types of algorithms for different types of data sets and how it is curated, how it is validated, and what are these percentage in terms of validation testing and all the parameters we'll be looking onto it. And in terms of prediction analysis, and these things more focused into personalized healthcare. Like we are aware about this, IoT plays a major role impact on it. And talk about also IoT technology. Nowadays, moving on to the area of Internet of Everything, which we call IoE, or Internet of Web of Things, or getting on to emerging area. We are all getting on to more in terms of network, where we talk more in terms of cloud networking. Then we more focusing on the edge networking, where predominantly we need to minimize the timing as more quick processing, where like in a wearable, we could see that the sensors are placed on the top of it, where decisions can be taken quickly instead of minimizing this latency and fast processing. Wherever we are getting into real-time applications, we could see more in terms of edge computing process, even in terms of autonomous driving, ADAS level 2, 3 cars and all, or smart cities and smart homes and smart wearables. All those things, edge computing plays a major role. So there we could see that's more important in terms of redundancy. And all those things are effective and efficient with the support of the backbone network, what we call network. As of now, we have been utilizing in terms of 5G networks. So very soon we'll be predominantly switching over to 6G. Like adaptability comes the next factor. So this we could see as the healthcare which we want to focus in terms of leveraging these parameters, which in terms of more accurate, more precision, less noise, and all those things will be playing off the role of AI and ML for signal analysis. When you talk about these things, as I said, that enabling technologies, when we'll be discussing in terms of the different types of DL, deep learning technologies, or in terms of RLL or natural language processing, as I said, edge computing, edge AI and IoT, and federated learning, which we are genetic AI and federated learning, where we are getting onto more in terms of focusing. We could see that more application oriented in terms of these technologies. And these are the few case studies in terms of all those things in terms of like cardiology, where you can able to predict in terms of more than 98% accuracy, or in terms of wearable or neurology, critical care monitoring. This shows that how significant all those things, which the topics are chosen across it. And like it results in enhanced diagnostics, real-time remote monitoring, efficiencies and all. So now we get on to this topic, which we have taken across is about digital twin. As Madam has rightly said in the introduction, what is digital twin as a mimic of the human body or mimic of the system, which parallelly runs across the original system, where it tests and evaluates how about its performance, how it is going to be operated, how it is going to be analyze any failures in advance, so that it can be able to predict it, not only predict it, we can able to stop it, we can able to overcome it. That's all the very challenging and very predominant predictive technology, and that's we are going to discuss on it. So that's basically the topic which I selected is like a digital tool enable intelligent healthcare services and future societal needs. You would have heard about IOMT or IOHT, where we could see like Internet of Things more specifically in terms of health technology or medical things, like in terms of analysis of signals, where the human parameters of signals which have been acquired from the human or the continuous monitoring. We are been aware about these technologies earlier too. It's not a new technology like we to call like a telehealth technology or telemedicine. Nowadays we call in terms of e-health, and we could see that like all the medical records are getting digitized. So these things like an evaluation which talks in terms of IOMT, IOHT, like in terms of everything. Now we get on to a new point, a term which we call like a digital twin. As the name itself indicates, like a twin, so there is going to be a replica or a Xerox copy or another copy or a carbon copy, however you could see, which is going to reflect the physical entity which is physically available in real time. So that's basically we call virtual replica of the physical entity. So we are going to see that's how it is going to be like active or dynamic, or how it is going to be to in terms of getting data. As I said, more amount of data are going to be driven. So that means in terms of data that relates into number of sensors associated. As we know that when we collect n number of sensors are deployed across it, we are going to collect or in terms of various data. So all those data are exchanged in terms of the physical quantity, in terms of virtual. The mutual exchange of data are getting across it. So we will be discussing also like what is digital mirroring, digital shadowing, what is called simulation, and what is called digital twin. So that's we in turn most focusing on human human parameters, human personalized parameters, or in terms of medical devices, or in terms of entire healthcare professional systems or the systems which are going to be monitored across it. So that basically it is going to be like a continuous monitoring, which we call like a real-time impact. So we call like a real-world applications, like how it has an impact and what are these opportunities and what are the challenges looked on it, and that results in a societal need. So whenever we talk nowadays, we always focus in terms of sustainable development goal, SDG, even the SDG, like in good health and life on earth, life underwater. There are many SDG goals, and this is going to have a greater impact in terms of future societal needs. That's the thing. So when you want to discuss regarding about digital twin, as I said, virtual model of a patient, and now we focus especially mostly on healthcare sector. So that's, as I said, we are going to evaluate, we are going to collect some more information from the human body in terms of it based upon the intended parts or intended signal which are being, so the sensors are deployed across it. When you are going to sensors, so then automatically it's going to be wearable, because it's not going to be like a wired connectivity where it is having more restrictions. So it is going to be wearables or a wireless. So when you talk about more in terms of wireless or wearables, we should be more focused in terms of what types of frequency are being operated. As we know, that's like we are come across like a LAN, WAN, MAN network. So we are also coming across a concept called, which has been evolved actually, like a body area network. So what are these components which are being worn over the body or inside the body or on the body? We call like an form factor of the device. Whatever we have now with the devices, whatever we carry across it, so it measures in terms of many parameters, like in terms of SpO2, heartbeat, or in terms of temperature, or many parameters are getting vital information are getting across it. So that's we talk in terms of even the images are taking across it. So we could see this collected from sensors, wearables, and medical imaging. So everything is going to be exchange of data as a stream. Like in real time monitoring, every data are going to be uploaded. So it is getting onto cloud, like putting on into a cloud-based server. But if we need to get an information or exchange or in terms of instruction, it takes much time to take a decision. As I said, edge computing comes over it. So that we are going to design in terms of how it is going to be accessed, how long it is going to be stored, how we are going to predict, how I am going to analyze over it, and that results in an we are going to have those parameters which are collected. It's going to be simulated and tested across the real entity, and which results in like in terms of what type of medicines we are being carrying out and what type of prescriptions are given by doctor in a routine work or in terms of surgery, pre-surgery or post-surgery. And after that, we are going to follow it up that results in a lifestyle changes and which results in different parts like in cardiac or different cases. So that's we are saying that the sensor which is going to collect this information then across a device, and that is putting onto the cloud, and how it is going to predict, and how I'm going to exchange data into a real and the mimic, or I can call like a virtual. So this is going to be exchange of data, which is going to be like a dynamic, real time, all those. That's basically we are applying the digital twin in a healthcare. So prior to that, we come across whatever we discussed, like it has been on various scenarios and objects like an dynamic simulation, predictive maintenance, and optimized performance. So that's about what we discussed regarding digital twin technology. To be more focused on it, like we get on into we call like a digital twin or physical twin or replica twin. So we get on into more like a mirroring this parameters. So I get on to this four P's, P4 medicine. So that's we call like an to make the healthcare like a predictive, preventive, personalized, and participatory, which we call like a P4 medicine, as which results in a resilient, efficient, and intelligent healthcare system with a less latency, which is going to have a greater impact on the healthcare system. So we get on to it, how it is going to be looked on it. So when I talk about the digital twin in terms of healthcare, we most focusedly on three predominant issues. One is about real-time synchronization. In synchronization, that basically how we are going to be in with a less latency. So that is going to be more on real-time data collection. So with respect to the simulation parameters, which is uptime or the data, how it is going to be interacted in terms of physical counterpart, like a physical entity and the simulation part, like in terms of different conditions, different temperature, environmental conditions, operating standards, operating conditions, all those things, are how it is going to be transferred accessible of it. And in terms of real-time entity, that's one is about real-time synchronization, and second is about data integration. As I said, enabling techniques. When we have a different parts are getting to be associated, how I am going to integrate and make it sure the process output is going to be moved on to the next block, or how it is going to be compatible in it, looking on it. So that talks about the models, the simulation models or design models, which gets across it, and what are the different types of inputs. Or whenever we run on in simulation, we discuss in more in terms of types of data sets, or in terms of real-time data sets. Sometimes we get on into Gaggle data onto it. So that's when we get down to like a product life cycle. At last, we try to make it even product or miniaturize, which we go for it. So that's about the product life cycle. That's where the integration comes to part of it. And third one, okay, we are collecting data. We are going to share this information. We are going to compatible of it. Out of it, what is the net result? What is an end application which we are looking on to be? So that focus about predicting. So that's in terms of real time, how I'm going to prevent it, how I'm going to overcome it, or how I'm going to follow it up like a lifestyle or overall monitoring in case of it. And that results in an alarm, or in terms of very critical situation, which is going to happen, buzzer line, which is going to be given uh, s- uh, immediate call to notice across it. So that's basically called real-time synchronization, comprehensive data integration, predictive capabilities. So that's whatever we discussed. It's basically put on to a simple diagram which talks like digital model simulation, physical twin. There you could see here the information or the data are shared in both directions, like a simulation model or physical twin. As in terms of physical space, left hand side, you could see here the process is basically collect, process, generate, update. So that means whatever the sensor which collect the information that is going to be sent across, sharing to a virtual space, and whatever the virtual space sends, it is going to be generated and it is going to be updated. So mutual is a continuous real-time application process which goes on across. This is the basic thumb rule which discussed in terms of digital twin, like collect, process, generate, and update. So that's the classic. To get onto a digital twin, we need to get onto how it has been evolved. Plus, find the name. What is the need to discuss? What is an accident or an incident which makes to talk more in terms of now digital twin? Like it has been applied in terms of various sectors, but now we are focusing on healthcare. So this goes on to 1970s, like NASA's groundbreaking Apollo program. That they were being facing a challenge in terms of launching the space shuttle, which in terms of where the challenges in terms of oxygen sensor, which they were not able to successfully deploy across it. So in order to make to be in order to make to be more precise, they need to have a replica model just to avoid the problem where they can able to successfully deploy it. And as we know that the cost impact in 1970s, you could see that how much cost it will be involved in terms of millions, in terms of $1 million. And in order to challenge the real-time problem solving and a critical decision with a low latency, That results in a concept called like an oxygen tank. There was an issues in terms of Apollo 13. That was the start point, which they talked in terms of discussing on a concept called digital twin technology. That's about this evolution. And the father of the digital twin is none other than Dr. Michael Greaves. In 2002, he has coined the name. Just basically, he is basically a manufacturing engineer. In a manufacturing engineer conference, like in product lifecycle management, he has defined this concept and named this about the digital twin. So that's about Dr. Michael Greaves' story. And based on it, it has been evolved. It has been evolved and get on to like as of now in terms of 2025. As we do that, it starts in terms of static 3D models and IoT was been more fascinated in terms of last 5 years. Then it was about the big data and cloud, then about AI and ML. Then we talk in terms of genetic AI, federated learning. Then we nowadays we talk more in terms of quantum computing, the process in terms of evolution of semiconductor evolution. Like government of India also supports more in terms of it. So that's about the technological evolution, starting from static 3D models to an AI and machine learning, like and more algorithms are getting onto it. And that shows about this evolution, which talks in terms of, and also we are now in the era of Industry 5.0 or 4.0 has been overcome as it's going to be like a mass production in terms of more personalized area, in terms of more personalized production in terms of it. That's basically we talk in terms of 2022, the sustainable condition, there's the evolution working on it. So when you discuss about the significance of digital twin, what are the components of it? Before understanding, then only we can be able to apply and deploy in terms of the healthcare sector. So when you talk in terms of the physical and the virtual component, so we need to know what are these level. As we know that when you discuss about in terms of network, like an TCP/IP model or OSI ISO layers, we start with the two 7 layers, like a physical, data, network, session, presentation, application, and all those things. Similarly, when we have a layered architecture, we will be having this concept like a from bottom to top approach or top to bottom approach, like a layered architecture. So that starts from the basic component, what we call physical object. So this is going to be either a machine or a building or a system or an individual or a human. That's basically individual object, physical object. The parallelly, we are going to have one more object, which is called digital model. So that's basically physical object, digital model. Then how it is going to be connected. So connectivity in terms of IoT, that's the backbone network. Then all the data which are going to be connected across sensors. And next one is got like a collection and prediction and how I'm going to analyze. So there we get on into the concept of an AI and analytics engine. Then about the interface, like an dashboards or any app which are going to look onto it like a visualization. So these are the concepts or component digital twin which are getting across it. So this, with respect to that, we come across like an start, as I said, we'll be getting on to the basic like a layered architecture. One, I will get on to the diagram, then I come across it. First is called component or part twins, and second is called asset twins. Third is called system or unit twins, and fourth is called process twins. We could see here when we move from left to right, this is like a cell, what we call the entire human body is broken into pieces. We call it a cell which we cannot be further subdivided. This is the smallest part in the body. That's too same applicable for a mobile communication to what we call even the smallest area in a physiological space or in demography should have a signal connected to the base station. Similarly, this is a component of the part pins is model. The collection of the part pins becomes asset pins, and entire combination of asset pins becomes a unit pins, and the whole entire process is called process pins. We have an example to understand about it. So based on it, we call part, asset, and unit pins and process pins, which we call like a component. This is a basic element, basic elements, and the combination of all those things in life cycle for a performance, then a system, then process pins. So that's about the basic thing. Here, we could see here, start from the component part, other product part. So that we could see here, we need to develop a motor to be operated. Like let me take a stepper motor. We need to devise model a stepper motor. How does it operate? So we know that either it can rotate in the clockwise or in anti-clockwise based upon the programming or based upon this in terms of circuit connection, either it's going to be reverse or it's going to be clockwise or anti-clockwise. So we are going to see this assembly of robot servo motor. So when we get into robot, we talk in terms of different types of hydraulic, in terms of pneumatic, electric, and hydraulic, and we talk in terms of how it is going to be like connected across it. So we call the links, joints, and the dynamics and dynamics are getting onto it. So this is a basic robot, servo motor, assembly robot. This is a part pin. And then we could see here at the joint, we have a motor which can able to move, which we talk in terms of degrees of freedom, how it is going to be operated. So that's a part of it. And the asset twin is nothing but when I'm connecting the different links or the hands or the robot, I call this entire structure like an assembly robot. So I could see here assembly robot is the asset twin. Similarly, I have a virtual model across it. So then we have a system twin. So now we're starting from a link. The two links are connected by a joint by a motor which is having a degrees of freedom DOF can operate. The entire system is called like an asset twin. Then we call the process twin. Like the process means in an industry, like in a car manufacturing, some parts are being lifted. For example, a brake is being placed across it, or a pedal, or a clutch, or a steering, or a seat, or a windows, whatever thing, something pick and place, or even a welding options, whatever we go for it. So that takes about the process. That talks about, sorry, prior to that, we call in terms of assembly. So I'm taking it and that is going to assemble. The car has been constructed, that has been placed across it, that's the basic thing. System twin. And from the system twin, the entire, like it, we have n number of system twins, n number of robots operated. The collection of all those things is called as process twin, where different options are getting across it. The last one, I am going to be like a wide area network. Okay, so I am going to the same industry which is located at Chennai or a Bangalore or a Pune or Hyderabad is going to be connected across different geography, different across the globe, which I call like an enterprise. So we could see here the ecosystem is being taken care. So that's basically we call like an part twin, asset twin, system twin, process twin, enterprise twin. Everything should be replica. The idea is whatever you do, whatever you execute, that everything is a replica of the model. And the replica of the model starting from the lower layer, like a part which we call physical layer, to the upper layer, which we call application, like it a part twin to enterprise twin, everything is a replica. Like information is getting collected continuously, it has been transferred, which has been exchanged. I'm going to update, I'm going to analyze, and what are we going to predict and able to have an that's basically we are going to look across. And this we could see here. This is actually in a cylinder where the pressure is being operated, pressure based on the pressure, the valves are getting open. And I'm going to see that how it is going to be. Here, this is an actual process. The right hand side, you could see a digital twin process where you could see that based upon the pressure, if this is on, when there is a 50% full, and what is the valve it is going to be crossed, what are the processes getting across it, and what is the top side link is going to open. So that's a similar thread. You could see here the exchange of data is from actual process to digital, and whatever the digital twin is getting across, they share the information to the actual process. So now starting from the part twin to whichever is getting across. So this we could see, like an what we call it robot. Actually, we are calling see, sense, act, and respond. Similarly, you are these that see, think, and do. So that basically from one component or the part, we get on into one process, asset process, then about the enterprise. You could see here all those things we are getting on into an uh, model to look onto it. So like we could see here, the informations are getting across over all those things are getting. So that's basically how we understand over it. So this we could see here. So what are the entire process? As I said, we are going to define like a parallel replica is going to. So when we're getting onto it, we are getting a slight confusion whether the different names are having a same meaning or all it's called as different or the process is same. Like what we call simulation. We run in a program, we evaluate, we work on to different platforms like in simulation. Whether the simulation in digital twin is same or not, whether how it is different. So we will just throw a light onto it level. So prior to that, let me have a clarity on it. So one is called a digital model, so which is going to be like a parallel of the physical space. So it is a manual data update that is not automatic. That's the main thing is given. Manual data updates, no automatic synchronization. The first thing, real-time synchronization, that is not happened. So that cannot be suited for a digital twin component. So the second is digital shadow, whereas in a unidirectional, what I call simplex, half duplex, full duplex. Like it similarly, it is an automatic, but moving better from manual, but it is going to be in terms of unidirectional data flow. So that's basically, and the last one, what we call digital. So it is going to be the replica where the decision, where the information is getting dynamic, and also it is going to be like a bidirect. So that's basically we differentiate in terms of digital model or digital shadow or digital twin, which are all different. And to be more specific, like in one-way data is bidirectional, and this is passive monitoring, this is active control. This is about the differentiation, and that's we could see here. The first one, digital model. We could see here, it isn't not automatic, it is manual. Second thing, it is automatic, but it isn't only direct, single direct, not bidirect. And third one, it is an automatic data, it isn't bidirect. So that's we differentiate into all those things. And next one, we should be very clarity in terms of what is simulation, what is digital twin. And this is dynamic, but this is simulation is on based on the conditions given across, is based on the static model, on a specific conditions, a scenario. We look onto that, and this is a predefined parameter, but this is a real-time process which we evaluate, we predict, we update. So that we could recall this initial diagram which we call across it, how this has been operated in all those things. Okay, so that's about the primarily for hypothetical conditions, and this is we could see that monitoring, continuous monitoring, predictive, and real-time challenges occur. So that we are very clear. These are all different, like digital shadow or digital twin, or in terms of uh, uh, digital twin dynamic model. Okay, and next we get on with architecture. As I said, starting from the asset model to the entrepreneur. So that's about the unit level, system level, SOS level, which we talk in terms of product like management, PLM. That's about the complex product and equipment. Okay. So now, prior to getting on to healthcare, I need to have a small view about like what are the other applications of the digital twin which we can look on to it. So it has a wide area of application which focus more in terms of like design and engineering or in terms of construction operation and demolition or recovery, which talks more in terms of it. Here you could see here, I will just focus on the potential applications across it. I could see it like a healthcare sector, which shows them the application is mostly on optimizing the care task performance and hospital's operation. So how I'm going to, what is the advantage? Like, and these are all different applications, how I'm going to design, like, and based on the model, how I'm going to look onto it, how I'm going to detect, diagnose, and personalize the care. So this talks more in terms of different sectors, energy, automotive, oil and gas, and it's about the smart city mining. It's all applicable for every sector, like in green building concept, education, agriculture. Okay, this is one sample which is taken like a wind turbine monitoring. As you know, wind turbines that basically operate based on the flow of air. So based on the speed, it is going to be generate the electricity, which is being stored in the grid whenever unnecessary. It is being used or it is being sold by the private parties or directly to the consumers or through government. So it is basically we have a peak area, peak time based on the locality. We could see here very tall locations across Tamil Nadu. We could see here in down south. With that we could see here. So I should be able to when we have a turbine, I should be able to process a digital time. So the massive construction which I'm looking across it. So that depends upon the speed of the wind. That depends upon the different moisture condition. That depends upon the environmental situation, how data are collected, how I'm going to store based on it. So you could see here the massive wind turbine. So that's I'm going to collect based upon the rotation in terms of blade rotation speed. Another thing, as I said, the temperature, the vibration. When it is placed very high, I could see that's based upon this movement of air. Either it's going to be help to fast up this rotation of the blade or it's going to resist. And sometimes when you ride on your vehicle in a road, sometimes when you are against the air, we cannot move fast across this vehicle. We will be having a restriction to move across. Similarly, when I want to measure some parameters in terms of wind turbine, I should be able to see that whether the wind is going to help in terms of rotation or in sometimes it is going to have an opposition. That's also like it measures also in terms of vibration and on the wind conditions of the temperature. So that's basically continuously evaluating all those things. I can able to diagnose that like how the more amount of energy is stored at what time, at what level of prediction, and what are the anticipate all those issues across it. Like if any prediction, for example, if I say something, I could say there's a 5-year life term. At the third year of some days, I am having a problem in this. If I can able to predict in advance, I can able to maintain such thing. I can able to correct it so that my entire process of real-time application can go on to it. Like a part of it is going to be continuously monitored across. This is a proactive approach. We takes an example. It does a wind turbine monitoring. So based on this, we get on into an enabling technology. As I said, the more in terms of the technology, enabling technologies or adaptability or compatibility, which talks most into. So when we are focusing more on healthcare sector, so that as I said initially IOHT or IOMT, and then AI and ML, big data analytics, cloud, and 5G current, as I said, 5G is the thing which we are going to have more amount of. We know that as of now, how much time we take for uploading and downloading, but more in terms of we more focus in terms of data. But actually, we are not exactly utilizing the huge benefits of 5G rather than other than the real-time applications. When you talk in terms of autonomous cars, nowadays we could see in every car advertisement like an ADAS 2.0, ADAS 3 advanced driver assisting system. It's every cars now. Last 1 year, we could see everybody starts into ADAS 2.0, 0 or advancement ADAS 3. We know that based on the SAE criteria, we had ADAS with a no manual driver into a full autonomy. You would have heard about the cars in US, Waymo cars. It is full autonomy or Google cars are tested across it. Even in last week, we had a news call that a car has been tested in Bangalore regarding the full autonomy car, so autonomous car. So that we could see that whenever you're getting into real-time conditions, that was, for example, if you take a car, you could see more amount of sensors are kept across it. We have more amount of radar, we have more amount of lidars. So I want to sense that how this traffic, how is the signal, and the continuous evaluation of the data is shared across it. And we know that in recent days we have been more focused in terms of V2X, like vehicle to anything, like vehicle to infrastructure, vehicle to pedestrian, vehicle to vehicle, so that we could see that more amount of information are getting on into machine-to-machine communication. Earlier it was we call human-machine interface. Now it is going to be like a machine-to-machine interface. So that's a part of this, or getting robots are getting more autonomous, or more robots are more getting intelligent. So that's basically all those things are effectively deployed based upon the 5G connectivity. But as of now, as an end user, as an individual, we are not exactly using all those benefits. But the real-time applications, like they call smart cities, smart homes, smart industries, smart factories, that the usage of like a telehealth technologies or IoMT, these are all the real-time data which is very crucial. Like latency is to be made much very less. In such a case, this 5G connectivity plays a major role, and that we could see that this is all an enabling technique which makes digital twin successfully deployed across. Okay. So now we get on to like an applications, like what is going to be in terms of personalized medicine, ECDC, disease detection, how I'm going to see the impact of digital twin, remote patient monitoring. All those things are already existing. It's not a new application, but across more in terms of digital twin, we are going to replicate the model. We are going to predict it. We are going to stop, or we are going to correct over it instead of happening a repair after it's going to happen. That's basically a drug development, interdisciplinary collaboration. And the last one, which is more sensitive, which we'll be discussing, like data security and privacy. Okay. So these are all the few use cases. And we call these are the references are given here from where I had taken all those things. Like we call the enabling technologies, the different things you could see here. Uh, Clinical drugs and patient remote monitoring, customized medicine, surgery, epidemic management, these are the things. And this I need to focus few cases, use cases. This you can make a note of it and you can just check out the website too. There are some few use cases like a real world healthcare examples I given. The first one is about Babylon digital twin for e-medical records. When you check across this babylon.gs, there is a software which is available where you can able to try to mimic your model based upon its which application you are going to be deployed. You could guess we can able to try to deploy your digital twin of for any models that we can check across Babylon. And second, you could see that hospital ward management digital twin at Matter Hospital, Dublin, where Dublin there has been. We know that whenever we are getting onto electronic health records, what they call EHR or EMR, all the data of prescriptions are getting all digitized. Like that has been put into repository and is going to be the continuous evaluation monitors are getting across it. That's about the second use case application is given. And third one is about the precision cancer treatment, which has been done at Mayo Clinic, where this application is deployed across it. And fourth one, as an university academia or in terms of medical college, where it could be the Stanford University, there had been digital twin application has been put on to cardiovascular research. So that we could see here that's about the fourth application. Then we have the pioneers in digital healthcare system, the GE healthcare. So how it is going to be in a predictive maintenance. And there's another industry and academia, institution academia, where you could see is Imperial College London about surgical planning. These are all the different applications where you could see here what are the applications in terms of real world challenges healthcare digital twin applies over it. And this I want to focus on it. And this we have a few other specific like in terms of it, personalized predictive maintenance, real time. This already we had been discussed. When we talk in terms of real time health monitoring, as we are aware that during COVID time, when we talk more in terms of temperature, SpO2 is a very critical area where whenever everybody start bought this machine apart from this thermometer which is often in our home. Now we could see as nowadays BP machine is very default in many homes apart from measurement of diabetic machines, all those things. Then you could see that the glucose level, then apart from this oxygen saturation, SpO2, that's basically which we call few parameters which are very critical in terms of disease reduction and also predictive and all those things these are all and using this AI-driven analytics we can able to be treated well in advance to countries. So that's about surgical planning, hospital operations, drug development, all those things. Let me get on to an each individual. We have some 10 use cases are getting on here. So I'll get on to few case attention. One is about patient digital twin for personalized medicine. So that takes care about precision treatment based upon. Is it okay, madam? I'm audible?
Yes, sir. Yes, sir.
Okay. It's basic about for an individual scenario, how it is going to be, which data are going to be collected, how it is going to process across it, and how it is data health or telehealth technology is going to be. So, like an engagement with respect to physicians report, how I am going to look on it. That's about the first case, like a patient digital twin for personalized medicine. Then about, like I said, on the body, off the body, like an organ digital twin. Suppose if you want to study more in terms of heart, or you want to study more in terms of lungs or in terms of the parts of the body, we should analyze about this anatomy of the structure. Like we need to have a physical model, like a replica of a model, how it operates, like when it gets the blood flow, when the heart is going to be operated, what are the pulses is going to be generated. So like an organ level digital twin for disease simulation. That's the second thing. So that's like able to see in terms of reducing risk in terms of it and enhancing in terms of very critical cases like in chronic cases. And third thing, it is going to be more onto safety cases also. So that's basically we talk in terms of an example is given cardiac digital twin, which talks about the heart function under different cases and different conditions. So that's basically so prior to this surgery, and even in terms of we can able to analyze how this whole set of this anatomy is getting to be understood for a person who has zero knowledge about these biological terms too. That's about the organ level digital. And third one, the facility. So as I said of it, the entire process, the entire hospital management, how it is going to be operated, resource allocation, the sharing information, how to predict and mitigate these issues and minimize the waiting times, like a maybe based upon this electronic health records, how it fast and how it can be processed across it. That's for the third one. And fourth one, like a telehealth or case sensitive cases, like as I said, IOMP plays a major role in terms of elderly people, where it could see more in case of Japan, even many countries, even in Germany, we could see as the average person's age is getting increased. So automatically, the more focus will be placed about elderly people. So where this technology is going to aid in to support all those the elderly patients or the chronic cases. And this is about the for remote and home-based care. And that's about the drug delivery system, the pharmaceutical research, and then about public health, pandemic management, which you had been wanted, which you had crossed across recent years, and about after that, if there is going to be like a replacement of its prosthetics on how we are going to get across from this, get back to the normal lifestyle and very quick recovery. So that's basically to understand about the progress and all those things, the recovery time, and then about the maintenance and optimization. These are all the different use cases and getting on to it, policy planning and all those things getting. So when we discussed all those, my topic which was connected across it, how I am going to like a future societal like a health care issues and all the parameters. So just to be support in terms of having an impact on society for a future healthcare needs. And based on it, we have a small video which I run it later. Okay, so this has been taken from an article which talks in terms of physical object, the patient, which the information is getting across, like in terms of looking across the lungs operate, how when we inhale over it, how the air flow movement based upon it, because the movement of diaphragm, how this is going to be operated, and what is the scenario, how much timing and how what are the pressures created, how much more amount of alveoli are getting expanded, how I'm going to think on it. So that knows about how this characteristics which you look on it, the link is given across it, it's about on this thing. And overall, as I said, like an enabled technologies. So we could see here like an the parameters in terms of patient, how it is going to be like an data connection or patient or interface and synchronization. This explains about the description, what are the enabling technology. For an example, what type of CT image or in terms of identifying the tumor cases and what are the treatment, for example, what is the necessary rectification like a diabetes. So this talks in terms of medical result in, so where that is going to be like a more precision and which is talks in terms of medical AI. And this is another article been taken from the Lancet Digital Health Journal, which is a recent journal, which is on volume 7 and 2025, which talks more in terms of the title called in terms of uh, medical digital twins enabling precision medicine, medical AI. So there we could see here the based upon like for knowledge component, all those things in enterprise stream, how this is getting onto the patients in silica, then how it is going to predictive, like what are the models here going to be, how many layers of CNN network, how I am going to use the data set, how I'm going to collect it. So that's going to be like a bidirectional where this gets on to be connected. That's basically, I think initially like a sensor, how I'm going to be connected and what type of AI prediction and how I'm going to see in terms of 5G connectivity or the cloud or the edge. So entire thing scenario talks in terms of enabling technology. This is another reference article which has been taken from a journal, Elsevier, Science Direct. And this, what next? What next? How it is going to be look onto it? As I said initially, genetic AI or federated learning or looking onto it. So that's we already the more researchers are getting into biotechnology or in terms of replica, in terms of DNA, RNA. So that's more in terms of physicals are now robotic surgery is very casual nowadays. Now it is being deployed across many things. So that we could see is mental health digital twins and digital twins for metaverse. Like when I'm getting on into more in terms of cloud structures and how it is going to be deployed across it. So predictive in terms of neonatal digital twins. So these are all the future trends which is going to be discussed in terms of twin healthcare technology. And as I said, very challenges in terms of it. As I said, when you're getting data and put across the cloud, how secure and how privacy is going to be maintained. It's a very big challenge across it. Like I said, whenever we get on to network, we should be double cautious, like how it's going to be. So one in terms of data privacy and security, which is a very critical aspect, which should be having an impact. And as I said, whenever these systems or evaluations are getting onto it, what are the standards which are going to associate them? What are the standards which are going to monitor how it is going to be operated across globe and what is the interoperability? As the many standards are defined. Earlier, it is all depends upon majorly on geographic conditions like when you talk 1G, 2G, 3G, 4G, it was American, there is a separate for European, it's a separate German for Norway or for Japan. But now it is getting on into very concept like a very compatibility and unity operability. That's the thing, one in terms of data privacy, second, interoperability, third one, regulatory and ethical concerns. That in terms of it. And fourth one, how we are accurate. As you know that even for a medical record, the medical equipment, when you go for a scan, when you go for X-ray, or when you predict something, the doctors or physicians, we always have a third eye to check whether these data are correct, whether they should go for a second check across it, because always they won't have much trust in terms of machines. There is an option for getting an error across it. So that's basically how we are going to more accurate. That this AI and ML, which are going to be more in terms of more amount of data sets, validation, testing, and all those things. That we will focus on model accuracy. That's basically which we look on to very priority. And this talks about like what are these challenges more specifically in terms of data security or ethical issues like a data integrity, regulatory issues. Let's talk about system interoperability and insider threats. What are the issues and what are the solutions? For example, if we take for a data encryption, like in terms of how it is going to be intercepted by malicious and how it is going to be. So the solution is going to be strong encryption protocols to protect data and to risk. These are all the challenges. Whenever we talk about challenges, there is always a way forward to look onto it, how it is going to be implemented on the solution. That's about issues related to security and data privacy. And second, in terms of like a more in terms of ethical solutions. So that's basically in terms of ethical issues associated in terms of long-term data management, security, and transparency, accountability, and mostly in terms of challenges, as I said, These all those things mostly will be on model operability, because when you talk in terms of IOMT, IOHT, like we are going to share this information across different devices of different stages. For example, if you take an image, whether it is going to be a Nikon images or a normal images, or how it is going to be operated, whether we are going to run a simulation model across it, whether we are going to test across it, whether it is going to be gray level image, or it is going to be color image, or when you different processes are getting, for example, like saying across it. That's basically model interpolability and model operation. That's basically very critical issues which talk for it, and more the standards and the evaluation. That's the basic. That's about which we talk in terms of what we call explainable AI, XAA models, or nowadays we all getting into automation. That basically which comes across it. So robotic surgery, which we call like a more precise, like an advanced robotics for surgery, and we talk now in terms of machine-to-machine communication, like we call brain-computer interface. So that's we could see it's more proactive and more active and more precise are getting across it. So that's next in terms of multimodal signals. So earlier we'll be talking more in terms of audio or video something, but now we are going to talk in terms of signals, images, and genomics. So that's basically integration of multimodal signals or data, like explainable AI, and this digital twin is getting on to be deployed very soon, which is being very part of this life across it. So how it is for simulation-based diagnosis, how I'm going to getting what is going to input from all those results as an end user, and then it's about the AI-assisted robotic surgery, which has been done. As I said, we are now moving on to 6G. So how it is going to be 6G healthcare network, that's going to be very, very fast and operability, or in terms of uh, more predictive, and how it is going to be more sensitive and more safety and secure. That's the basic thing we can go ahead. And as a road ahead, as I said, federated learning, blockchain, as I said, I had not touched about it. Blockchain, federated learning, metaverse technologies, which this twin care technology is going to have an impact across it, that will be looking at it. So in general, I can conclude that, and whatever these technologies are enabling technologies which are going to help us in faster diagnosis and predictive healthcare and personalized treatment in very short, with very less latency, and which we call like a next generation healthcare, where we are going to have uh, good facilities across it, where it is going to adapt of it. And when you are taking into consideration of all those concerns, like in security, interoperability, ethical clearances, and where it is going to be like a very challenges if you want to be more secure across it. So, like in terms of prediction, in terms of optimization, all those things are like a more and more in terms of policy makers or in terms of researcher clinicians, that everything will be a data driven society or data driven country. That's about conclusion. And that's I conclude my session. Thank you for a patient listening. If there is any questions, I think you can put your question. Thank you for a patient listening. This is my contact details.